here. And cosine function. All right. So now, so far at this point, when I've been calculating, when I've been showing you, then sine is more like just a way to do the calculation, right? So, for example, okay, you guys have your unit circle with you right there. So, sine of a pi over 2, for example. Okay. So, what's the value for that? 1. All right. And then the same calculation, but we can, so the idea now, the way I want you guys to see now at this point is sine is an operation that takes operating on that pi over 2 as the angle. So pi over 2 is the angle, we apply the sine operation on top of that so that we can get some kind of value coming out of that, right? And then so I can also switch to a different angle. How about for pi over 4, for example? We can also apply the sine operation, right? To do the calculation. So in mathematics, an operation is basically a procedure, a calculation work, right? That we're doing. So we apply the calculation for sine, and really, it's just the way we read it from the table. I mean, from the unit circle right there. So sine as an operation, apply on top of your angle, different angle for sine, right? Pi over 4. What's your answer there? Root 2 over 2. Okay. And so now after trying a few, and we've done a lot of these, right? Throughout your assignment, you can also go sine of a 0, right? A different angle for that. But the generality in these problems here is that we apply the same operation on different various angles. And so now this angle over here comes out with sine value being 0 as well, right? So I started using that term, but now what I want you guys to now realize, the reason I repetitively working through these is because now we can treat the angle here, any of these angles, we can treat them as an input. Well, I'm saying that we provide this operation a value we call an input. So angle here we regard to that as input. Okay. So the input here I'm seeing, the way I'm seeing that, we call it's the angle that we provide. Right, so that we can apply the sine calculation on top of that angle, right? But then the answer that you guys have been telling me, right? The answer here is the sine value. Now I see that as the output. Okay? Square root 2 over 2, some final result here. I see that as an output. Okay? So say right here, when the angle is 0, taking sine calculation on that angle, right? Applying the sine operation on that angle, we come out with an output being 0. So they may look the same, but they're not the same meaning at all. This is the output, right? The angle is 0 in radians. The output here, think about on your unit circle. Right? You write there as on the unit circle y value, right? Or you already drop 1,0 with that. That's why. So the sine value gives out the output's value being the vertical coordinates, right, on the unit circle. See what I mean? So now, why do I bring you into input and output? Because now I want you to realize, hey, wait a minute. So in the end, the sine operation we've been working with, we can consider that as a function, and that's why I've been using that term, but we never formally get into that concept until now. So now, anytime that you realize that, hey, you can take an input, right, and do your operation and come out with an output right there, that operation qualifies perfectly being a function. See what I mean? And so now, in that way right here, that's why we're looking at sine now, not only a calculation, but we can completely define a function. Right? So as far as function, right, we can define a function that, hey, f of x, right, where x is just the usual variable, okay, but we define that to be a sine function, right? And the sine here takes the input x. So the input here is playing in the role, when you're actually doing the calculation, the input here is playing in the role of the angle. And even though we switched the variable's name right there, we've been using theta a lot of times, and it still doesn't hurt to use theta at all. It still doesn't hurt to use theta. But now, the point now is keep in mind that we can define a function, so that the function is defined that anytime you give an input, you take sine value, right, of that input right there, and then whatever the output, we're still going to come out to the traditional y value. And so now seeing sine here as a function, right? So I'm seeing the sine right here as a function. Then let me now switch to the other board. And I really want you guys to I really want everybody to help me out with quite a few calculations right here. So as far as inputs, then outputs. Okay. So how about for inputs? Let's go with, and of course here, our function here is y equals sine of x, right? Or a little more formally, f of x, right? Defined to be for any inputs. The rule says we take the sine value of x to get the output. Good. So how about I'm going to really put in a few outputs. I'm going to suggest a few outputs, and you guys do the calculation for me. I mean, I'm going to suggest a few inputs, right? And you guys are going to suggest the corresponding outputs for me. And don't worry about graph or whatever. So we have done 0 already. We have done pi over 2 already, right? We got output 0. We got output 1. We got what was a pi over 4. We got output 2 over 2 correspondingly, right? See what I mean? So how about let's take the divided responsibility here. Can someone do 3 of these inputs for me? And I'm going to have to extend further. For inputs, pi over 3. Right? So can someone take pi over 3, pi over 6, and the 2 pi over 3 for me? And then can somebody get for me 2 pi over 4? Okay. Can somebody get for these 3? Pi over 4, so there's a 7 pi over 6, 5 pi over 4, and I also need okay, so for pi over 3,
Root 3 over 2.
Root 3 over 2, okay. Right, that's the input. So namely the work here is that we took so to get to that, right, you took sine, and just as usual, right, sine of pi over 3, that's the setup for that as a reminder. See what I mean? So go ahead.
1/2.
1/2. We all good? Then what about that one?
Root 3 over 2.
Root 3 over 2. And you guys always have the unit circle, so if you're already fluent, you can depart from your unit circles, right? But right now, feel free to use your unit circle if you feel like you're not that fluent yet.
2 over 2.
Root 2 over 2, sine, okay?
1/2.
1/2.
0.
0. Right? So corresponding output to that. Right? And yes, the work here is really, yes, again, just sine, right? We're taking that operation, so now we see that as a function, right? We apply that function with inputs 3 pi over 4, and then that comes out with the output. See what I mean? Right? Who are taking these 3 right here?
Negative 1/2.
Negative 1/2. Right? Right. What about the outputs here?
Negative root 2 over 2.
Negative root 2 over 2, right? And what do we have here?
Negative root 3 over 2.
Right? Negative root 3 over 2. And make sure you guys all double confirm as well, right?
Negative 1.
Negative 1, right? Negative root 3 over 2, right?
Root 2 over 2.
Negative root 2 over 2. And then, what about for the inputs? That's the outputs. How about 11 pi over 6. There's 2 pi here. Negative 1/2, right? There you go. And what about this one here? 2 pi. Yes?
0.
0. Very good. All right. So we've been doing what's famously called the table of values, right? You go inputs and come out with outputs. And of course, I may or I may have not to put all of these inputs in some certain order like that. But now with technology, we can also do that. So you guys can go ahead and put that as a table with these inputs in a certain order like that, right? Put these in the order so that it can help. So let me now show that on the screen right here. No, I have to apologize that the technology I'm using here is not showing the exact expression with root, but instead it's showing decimals. You know what I'm saying? But you guys already have these values, so you should be having some clear understanding. But let me start out with this. Right? When input was 0, right? You agree what the output was 0 right there? Right from our table, right? And I now purposely put these in a certain increasing order like that. And then, so does that agree with your calculation work with that? And then so now the next angle I put down was, right, I didn't put that in order earlier, so now I'm going to have a pi over 6 right here. The answer will come out being a 1/2. Did you guys agree with that? Whatever it shows right here, right? You ready? Right. And so, just like that, now I'm moving over to, there's a pi over 4. Right? And as I put in these angles here, you see how the point jumps up like that? Right? So, the idea of graphing now is that, see, we make our spacing. We make our spacing so that, and the scales here is depending on our choice. Let me get back on the board and explain this. But when we're putting these, when we're about to put these on the LCA sign as a function, right? Yes, when we're graphing it, the input is always placed as a rule, like we've learned back in pre-calculus 1, right? Then you always put the input on the horizontal axis, where you name that the x-axis, right? The vertical axis right here is to represent how high the output reaches. Sometimes it's positive, sometimes it's negative, right? And so now the only little thing we never done this before is that the pi, these pi units right here, the pi itself numerically is a 3.14, something like that, right? But there's no need to get that precise. You see what I'm saying? Now, this is how you can do it. You guys are majoring enough to see this. Hey, when you actually put things in a picture setting right here, yes, you can call it 0 right here. You don't need to go, hey, 1 is here, and 2 is here, and then 3 is here, and then try to find a hard way of having a 3.14. You don't need to do that, because scaling on your graph at this point in your majority math right here, scaling on the graph is on your own choice like that. So here's how about this. Just pick a space right there. That's 0. You pick a space right there on your choice, right? You call it, it's a pi. See what I'm saying there? Make sense? Because just a space right there, because when you're looking at a graph like this, right, how big is a 1? Nobody knows until you decide it. See what I mean? So in this situation right here, we can see that, hey, our graph focus on those pi units, right? So we just pick a space right here, we call it pi. See what I'm saying now? And then, by the way, I just realized I made my scale a little too small, but really it's all your choice again. How about pick that? I call it a pi. A little bigger, but in the end, it's all, my point is that when you graph these signs, and generally speaking, when you're putting things on a graph, then you make your own scale, and you decide your own scaling. See what I'm saying? No? So if about that big, you call it a pi right here, then double up that distance. You see how I'm doing my finger pointing like that? Double it when you're trying to fix that distance and go one more like that, right? Does that make sense? Because you already decided your scale, that was a fabulous work. Once you decided your scale, doubling that, you got a 2 pi, right? And then triple that, you got a 3 pi. See what I mean? Right? So now, what about from 0 to pi here? What about a spot exactly halfway? And I'm not an artist, so I can't even get the exact point, but ideally I want half that distance. So what's the number to put here?
Over 2.
There you go. Okay. And then so exactly halfway or midway between pi and 2 pi, what's the number to put here? There you go. You guys see how the scaling work out right now? Right? And then even, now when you pick the quarters, halfway between 0 and pi over 2, what's the number to put here? There you go. Right? It's another half of a pi over 2, right? Or a quarter of the whole distance. See what I mean? Right? And so now the idea that you saw on the screen earlier is that when you're at the angle 0 or the x input being 0, your y value came out 0 according to the chart. You guys following? And that's why we had a point here. And that point you saw it on the board. It's this point right here. And you see how my board is, how my graphing space is also being spaced out just like how I'm doing that. See what I mean? Right. All right. And so now we can really get back on here and confirm with that. And maybe it was a little rushing in terms of getting those pi over 4 and all that in the pi over 6, but forget about the pi over 6 and the pi over 4. Right, let's do this. Right. The easy ones. Let's look back at the easy ones. So we got 0, right? What about the pi? When you're at pi right there, what's your output value? You're also at 0, right? No sign, right? And then at 2 pi, you're also at 0. You see that red point that popped out right there? Way at the end, right? And that all agrees with your calculation, right? And then now I'm going to fit in some value between. So between 0 and pi, there was a pi over 2. Does that agree with your calculation you gave me with that? So y value, right, the output value agrees exactly with what we had, right? And the output value, we put that to line up with the vertical axis with that. You guys agree that? Right. And so just like that, between pi and 2 pi, we had a spot, or we call it as a 3 pi over 2. You guys made that scaling for me, right? And so with that angle right there, what was our value? -1 cosine. So when you're reading a graph from the left to the right, it goes like this. From 0 here, it goes up, it goes down further, right? It hits back to 0. See what I mean? Right? But just only a few points right here is not enough to see the complete shape of the graph. Because let's put in more points. Let's put in more detail in there to see the complete structure of your graph. See what I mean? Right? And so that's why now between the 0 and the pi over 2, see back on my board, I was explaining that. See between the pi over 2 and the 0 right here, we can put in a lot of other points like that in between. There's a pi over 4 exactly halfway, right? And then there's a, you can do your best to break that distance between 0 and pi over 2 into 3 equals little spaces right here. See what I mean? So that's why I'm putting that in graph right here. So that's a pi over 6 because 1/3 of that distance, right? 1/3 of pi over 2 is a pi over 6. You guys agree? Right? And then this is a 2 pi over 6, but that reduces down to a pi over 3, right? So this spot right here is pi over 3. You guys following? Right? And so now even machine is not able to do that, but for us here, we can understand that. And so I'm going to get back on my machine right here, adjusting scaling a little bit. So right there is our pi over 2, right? You see the pi over 6 and pi over 3 is exactly breaking our pi over 2 distance to a 3/3 like that. Okay. So now I'm going to put it, so we've got between 0 and pi, right? I'm going to put in the pi over 6 again. And so what was in the calculation? 1/2, right? And that's why we had this point just newly popped out right there. You guys follow me on that? Yeah? Right. And then after that, we got a pi over 4. So pi over 4 now is exactly halfway between 0 and pi over 2. So it has to be right here, but we're going to expect some kind of point, point being plotted up there. So over 4. See that point right there? That just popped out, right? So this time right here, we realize the graph is not going straight up, connecting these 2 points, but it's kind of going bent, right? So let's put in more detail here. Okay, so how about after pi over 4, but before we get to pi over 2 right here, let's put in the pi over 3 right there. Okay, you see that other point? Okay, so it's more convinced that it's going in a curvy way, right? It hits high in there, and now I'm gonna fit in between pi over 2 and pi right here. We got that 2 pi over 3, so I'm putting 2 pi over 3 in there. 2 pi over 3, that's about it. Root 3 over 2 like that. The decimal is 0.8, the 6 up, right? That's root 3 over 2. So we got a point that's falling back down here. So now we're even more convinced that it's going in a nice parabolic bent down curve, right? Right. So we continue with that. I'm gonna now. The point is not that spot here is not shown on the graph right here, but we're supposed to hit the 3 pi over 4 right there, exactly halfway between pi over 2 and pi. You guys agree now? Right. So I'm putting that in there. And there's a 3 pi over 4, right? You see how the point is dropping down right there as we go from the left to the right, right? And so continuing in that, I'm looking at that 5 pi over 6, right? Which is right there. See what I mean? Do these heights all agree with your calculation that you've done previously? The 5 pi over 6 and all that, right? And then there's the next one is the pi over 2. We dropped right down on that. And so it looks like a nice dome shape a little bit, right? That bends down and going up and then hits to +1 as the high and falling back down. See what I mean? And then so we can put in the other values like that. So between pi and pi over 2, right? I mean between pi and the 3 pi over 2 coming next right there, we got, yes, there's a 7 pi over 6, right? We've got a point being negative this time. Right? And then those are all, that's why, I was hoping that you guys all have these copied down earlier on the table. Here we're just arranging that so that we can see from the left to the right, and it starts showing that that major looks like some kind of wavy curve, right? Wave up right there, and swing its way down. And right now we only have those scatter points, right? But they already line up into some kind of shape like that. See what I mean? Okay. And so let's do further. So I got just now the 7 pi over 6. I'm gonna get in with the next one here. How about exactly halfway between pi and 3 pi over 2? So that point was not shown in here. It's not shown here, but it's a 5 pi over 4, right? So putting in 5 pi over 4, and the answer you guys gave me earlier was negative, right? The outputs that you guys gave me, see, negative square root 2 over 2. It popped out that point right here for me. Right? And so now of course I'm standing in the way a little bit right here, but so the next one here is before we got to a 3 pi over 2, we got 4 pi over 3, right? And that point, oops, 3, right? And that point pops out right here. See, that point, right? Then so now it's more convinced that that it's going in that wave shape, right? Right. So now I'm going to complete the rest of that. Okay, there's a 3 pi over 2, and so now between that, right, I'm going to go 5 pi over 3. Right, you see another point I popped out there. Can you guys see that behind this table a little bit? Right. And then there's a 7 pi over 4. Right. There's another point that pops back up right here. Right. And then we have the last one here was that 11 pi over 6. Right. That completes this point right here, and then the 2 pi. So the graph is not showing it here on the visible area, but it's right there at that point. See what I mean? All right. So with that, I'm gonna put the screen back right here, and then as I make some zoom out right there, then see, as I make some zoom out, is it more convincing about the shape of the graph? Right. So looking from afar, what do you see about the shape of the graph? It's swinging up in a wavy way, right? In a bent way right there. It's waving up. It's waving up, right? It hits a high, see what I'm saying now? And it turns its way back down, crosses through the x-axis right at the 0, meaning crosses through the x-axis right at x equals pi, right? And then keeps swinging its way down in a wavy way again, right? Hits down to a low over here, and hits back to a 0 again at exactly 2 pi on the graph again. See what I mean? So now, so in the end, you got a nice smooth curve right here. That it goes like this, right? See the shape of your sine function right there, right? So the graph of the sine function is a wave, actually. Yes, it's a wave there, right? The way how I'm seeing it is a wave that swings. So it starts at 0, right? It swings up, right? The highest height that it hits is 1. You know what I'm saying now? And then after hitting 1 for the height, it's gonna drop down, right? And of course, reading the graph, we always go the inputs going from the left to the right because we're increasing the inputs, right? Numbers are arranged low to high, from the left to the right, always like that, right? And so as number is increasing from the low to the high, from the left to the right, the high here hits 1, but then drops down, right? And drop down hits 0, and keep dropping down, hits the bottom. And see how low was this? Does that hit? -1, right? Hits you as low as -1 and hits back up right here. So the highest it hits is 1, and the lowest it hits is -1. Is that consistent with something we have learned earlier? See, so on the graph right here, it hits a high at, and you can also make your scale right here. 1, -1, right? The higher it hits, right there, waves up, waves down, it hits 0 right there. It's that, swing back up. You know what I'm saying up? Right. But the highest it hits is 1, the lowest it hits is a -1, right? And of course, I'm not an artist. So, but in the end, remember that I pointed out sine for any angle, right? The output comes out only anywhere from -1 to 1. Don't you guys remember this? Okay. Now that's also explained graphically, right? The graph nature over here, the graph can only reach as high as vertically 1, right, and reach only as low as -1. You know what I'm saying? No? Okay. So that's the nature of your graph. The graph for sine. Good. But now, so here's the thing. So everything we have done so far is only based on one complete rotation. because the graph so far we've done is only the graph we've done so far. Right? It's only anywhere from x is. I started with 0 for the angle, right? And I finished at 2 pi. You guys saw the one? And that was was remember one rotation. But see now you're on the when you're talking about angle opening up, and we don't stop at just one rotation. Why do we have to stop at one rotation, right? And that's why we spent some time learning about coterminal angles, because see the angle opens up one rotation, but it shouldn't stop there, right? So 2 pi is one complete rotation, but what happened next? We can keep going, right? We can continue rotating, right? To reach another rotation like that. So think about it. In your graph, this is how it goes. Pi is here, 2 pi is like that. So that distance right here is about exactly one full rotation. Okay. But then, like I said, like I just described earlier, we never have to stop at only one rotation. We can keep extending. So how about from 2 pi over here? Another complete rotation means you have another length being a 4 pi over here to complete your rotation, right? And so your graph, the first portion that we have drawn, 1 to 1, we sketch the graph like this. So pi over 2, right? 3 pi over 2, right? The graph went like this. It hits 1 in a back way right there. It hits down to 0. It hits down to -1 at the 3 pi over 2, hits back. What do you think when, so there's a 3 pi over here, halfway between 3 pi, so we go just that distance, one more step up over here. What angle is this? That's right, pi over 2, right? Because this is a 2 pi, and we're adding that with a pi over 2 like that, right? So each one of our base scale right here for now, right, is a pi over 2 space. Are you guys with me on that? So 2 pi, one complete rotation, we add with another additional pi over 2 steps away, right? That's why it's a pi over 2 as your classmate here was calculating it for me. You are saying that, right? But then so, think about it. Why don't you guys quickly do a calculation for me? Sine of pi over 2. Look right on your unit circle right there. Sine of pi over 2. It's 1, right? It's 1. 1 because it's what? Pi over 2 is also here. It's coterminal with, see, it's pi over 2 in one rotation, right? And it's also coterminal with 5 pi over 2. Coterminal. Okay. See what I mean? Right. So that's why it hits back to y value being 1, right? So the output here being 1. Good. Right? Hits back to 1. What about when it hits to a 3 pi? It goes back down to a 0 like that. And I can assure you that the shape right here also goes exactly the back shape just like that, right? So now by the time that we completely see, and what about the halfway point between the 3 pi and the 4 pi right here? What angle is it? Somebody else? Okay. So pi over 2, that's right. So now when we get there, what's the output value that we can have? Sine of 7 pi over 2. Negative 1, right? Yep, negative 1 about the scale down here. Okay, 1. You see now there's another wave exactly like that being replicated. Right. So, and that the story doesn't end there. So the idea is that what happened if we keep adding more rotations, then we're going to get to a 6 pi, right? And there's another wave that comes like that. See what I mean? It keeps goes on and going on, right? And so, what if you have, think about, so if you're starting at 0 over here, there has to be some angle before 0, right? Like some negative angle before we turn to 0 like that. So, think about, what if you were at the negative 2 pi over here? And then there's negative pi, mathematically, and then there's negative pi over 2 right there. Right? And then there's a negative 3 pi over 2, right? So negative 2 pi is here, and then we're rotating that one rotation to hit to a 0. You guys with me there? Okay. So the graph on the negative side looks like this. Right. So it stays the same, right? 0 is here, 1 is up, 0 is here, -1 is down here, right? Goes like that. And swings back to that. See what I mean? Right. And so this is why now when you're looking at the complete graph of the sine function, this is the graph, right? This is the graph of y equals f of x, that equals sine of x. Okay. Complete graph. So now on the complete picture, let me show you how fascinating it is. Okay, now this screen right here. So, ready to see that whole graphic there? The complete graph is like this. As I zoom out, see, it's never going to stop. It's going to keep waving and waving and waving. You know what I'm saying? No? Okay. It's going to keep waving and waving and waving. And so in this way right here, this is the reason why sine of x is being referred to as the periodic function. Okay. So, this sine of x, you saw the wave nature right there, right? Sine of x, right, is a term here people use periodic function. Periodic function. So why is that? Because now when you're looking at the graph, and I don't want to keep swinging back and forth on that screen, but the graph looks like this. 2 pi, right? Halfway, that's a pi, and then there's a pi with 2 here, and there's a 3 pi with 2, right? And so, just like you already see, 1 is the high, right? -1 is low, we hit high, it's back to 0, hits down here, and that. So the rest of the graph really is built on that one complete unit, right? So that's why it's called periodic, because it keeps repeating itself. You know what I'm saying? As we go further, right? 3 pi, there's a 4 pi, right? I can just close my eyes and make another replicate that exact basic piece we get. Here, here, here. Right? That's why it's periodic in that sense that it repeats itself after a certain amount of periods. So the total interval that defines one complete basic unit right there, we call it as a one period. You know what I'm saying? Huh? So in every period like that, right? And it's gonna start repeating itself. That's why it's called a periodic function. A function being periodic means the graph or the function itself repeats the value every time that we reach. Periodically one interval like that, right? And so just like that, we can keep extending. See, another period like that, right? Another period like that. That's why sine of x is a periodic function. Right? You guys get the idea? And so now speaking of that, speaking of periodic function, so when I teach my students in the graph of these trig functions, and specifically right now we're looking at the sine of x, right? And I want you guys to just focus, because like I said, just now, sine is a periodic function. And so the real key for you to be successful is just to pay attention to that basic building block units of that. So this first one that we built, right? I call that as the fundamental units of that. Fundamental units. The building block unit. Because the rest of the class, I mean the rest of the graph right here is built on that fundamental unit. You know what I mean? Or sometimes I also call it as a basic units. You got one basic unit, and the rest is built based on that. Because it's just a duplicate of that picture over there and being replicated. See what I mean? That one unit's from. So for this sine right here, you see how the wave ends there? The picture is telling you, right? One complete wave is right here. So the basic unit starts at 0, right? Ending at 2 pi, right? And then it waves up, waves down, and then it does the picture like that. So now let's look even a little more. Let's look a little further into the basic units of your sine function. So now let's look at the basic units, right, of sine of x, basic units, sine of x, that function. So basic units, I mean, it's always starting out from 0, right? On the x-axis, on the input axis, ends at 2 pi. And then see, the way how I'm seeing it, there's a halfway point, right? There's a halfway or a midway point there. So 0 is here, the halfway point is called the pi. You want to say that? Okay. And then there are the quarter point here. So these pi over 2 and 3 pi over 2. So in the total window over here, where we have one complete basic units, right? The basic unit goes like this. The high is 1, the low is -1 in my scale, right? It hits up. So it hits to a high peak at the first quarter. You guys following? Right, that's the way how you see it. And observe the way now. Don't worry too much about taking notes right now. I want you guys to see the way how I'm doing that in real hand action. See, the first high is at the first quarter, right? And then it's just, you don't have to get exact with these points, but in a wavy, in a curvy way of drawing it, you can just make some curve that's curved down and hits 0 right at the halfway of your complete unit here. So in your complete unit, it's going to hit 0 right at the halfway point, is what I'm saying. And then the third quarter point, right, where does it hit? It hits to that lowest point here in the -1. So it goes like this. See the way how I'm drawing that right up? I don't even have to get too precise about those points in between, but it's wavy enough for me to see, right? And then from here, the low peak, down to that, hit like that. So that's one complete basic unit, right? A complete basic unit of your sine function, because the rest, I'm not too worried. The rest is just, like I said, the copy and paste version of these, and we could put more those over. So first quarter, see, think about when you get out of class today and for the rest of the time, when you hear sine of x, right? Close your eyes and imagine. It's always going to have to be, I don't even have to put these scales on, but close your eyes and imagine this. See, no matter how small or how large you put your scale, halfway, quarters, right? First quarter, it hits a high. See what I'm saying? Hits down to a low, right? And then third quarter, it hits to a low, -1. Hits down. You see how I got the graph so easy right there? Because it's the feature, the attention catching feature of your sine of x function right there, of your sine of x wave right there, the basic units of that. And so now, let me even get in with further detailed information about the basic unit of sine of x. Okay. See, the start, I mean because this interval from 0 to 2 pi is the interval where we have one complete basic unit, right? Because the rest outside of that, it's just going to be the exact same unit here being rapidly replicated. So with this basic unit right here, where does it start on the input axis? It starts at what? X equals 0, right? Where does it end? So I highly recommend you guys start clicking with these. Anytime you're looking at the sine of x function, nail down where the start is and where the end is. So where's the end right here? The end is at what? X equals, there you go, 2 pi, right? Finish like that. Left and right, right? Left and right. Does that make sense? But then see, from this start to the end, how much distance did we go with that? The total distance here is called the period, right? So the period is just simply the ending point, subtract the starting point, right? We got the total space between, see what I'm saying, or the total window that restricts your graph, right? So I call that as a period. So the next information here, the period for your basic sine, right? Period. So you got start and you got end. You know what I mean? So the period here is a 2 pi. Now 2 pi here is the amount, the spacing. Right? It's not the point. The point, yes, we put a mark down, we call it 2 pi, but because of that, we define a spacing that big, and we call it a 2 pi period. Am I making sense? Okay. And so think about it. This is not a requirement here, but the way how it is, the ending value. I mean, the ending value is always the start, right? plus with the 2 pi period. You guys following? Okay. And then a lot of times people write the period here as a letter P. P equals capital P equals 2 pi. That's how people are indicating it. Period. Okay. But so see, the ending point is always the starting point, right? Add with that space 2 pi. Add with that period. And then your wave right here, wave up and down, but there's a line right here. You see what I'm saying there? There's a line right here. Some textbook author call that the midline, some textbook author call it the center line. Either way you want to call that, okay? But so there's always a horizontal center, or sometimes people call it midline, right? Ready? There's a center line or there's a midline. So the center line or the midline right here for this basic unit right here. Y equals 0, right? That the x-axis. Another way of seeing that. Equationally, y equals 0 as an equation. Right? But then what is it? What is that equation? It's just the x-axis, right? So the midline for your sine of x right here, the basic unit for your sine of x, got the midline as y equals 0. You know what I'm saying now? Right. And then there's another detail right here. The total spacing between the center line. So it's so important to know the center line because from where the center line here, the wave hits high here. How much distance is this? H equals 1, right? The height. And the same way right here, from the midline, from the center line, the wave hits down to as low as, again, 1 units away from the center line. See what I mean? Right? So that height right here, where the wave swings away from the center line, we call that as the amplitude. Right? So that much distance right here, we refer to that as the amplitude. Okay? So in this case of yours, the amplitude, right? The amplitude for this wave right here is 1. Let's call that h equals 1. Right? Right? It's just the distance. See? Make sure you draw that. If you guys taking note, draw that. The little picture here. It's how much spacing, the physical, the positive spacing is from where the center line, right, to the high peak or to the low bottom right there. See what I mean? That total distance right there, from the center line to the furthest point on vertically up and vertically down. The furthest point that it goes down here is -1. So the amount of amplitude is 1. Make sense? Right. So just like that, here we got the cosine. So cosine can also be defined, right? So as far as a function, we can define a function y equals f of x to be cosine of x. Simply that comes out of that operation that we can go with the cosine of different values, right? Any one of the angle that we have done earlier. So for example, the function evaluated at pi over 3, right? That means now we take cosine value for the inputs being pi over 3. And so the calculation comes out as usual, right? So the cosine of a pi over 3 is 1/2, as we already knew. So things like that. So my point now is that we can, after observing that cosine we can put it in different inputs, right? Similar to what we've done with the sine function. We've got input, and then the value that after we calculate the cosine, the final value right there, that's considered as the output. And that's why we can define a function, f of x, where we call that cosine of x. Okay. So just like that, once we're define a function that's called cosine of x, then we want to look at the graph of that function, right? But let's start out from the basic ground right here. We need to build the table values again. So when the inputs angle, right? When the input as the angle takes these, and I'm going to leave a few empty ones here. Let's look at the 0 angle. So output here means you're going to calculate cosine of 0. Right? We want to figure out, and we want to figure out the output's value right here after checking cosine of 0. And then same way right here, we want to. So pretty easy to work right here. We can just look at those common angles right around your unit circle. Right? So pi over 6, pi over 4, and then we got some more, and pi over 3, and so on, so on. So this is the idea over here. Now, you guys probably don't need to copy this down yet. Let me bring down the screen right here and show you what's on the screen right here. That's the idea of the table. So the table you see on the left here. So this time I want to leave that for my class, for my students, to fill out these values right here. So these are the different inputs, right? And then, but this time we want to calculate cosine. And then so you guys go ahead and do the calculation independently. So we got angle 0, right? And pi over 6, and feel free to use your unit circle right there. So calculate for you the outputs on any of these input angle over here. So we have got the angle already provided here in our table values. And we go at least completing out a unit circle, and we're looking at those angles from 0 and all the way up to the last one here on our list is a 2 pi. See what I mean? Okay. So go ahead and take a few minutes to get these angle calculated. Right. So I got 0 up to 7 pi over 6 on the screen right now, and then when you need more to scroll out, scroll up like that, let me know. Alright, so when the angle is 0, right on my chart, I'm ready to input the answer right there. So, alright, so immediately you see a point that popped out right here, right on our graph, right? So cosine of 0 is V1, and that's the whole idea about graphing it. Cosine of 5 over 6. Root 3 over 2. Right? So square root of 3 over 2, right? Got that point like that, and yes, I agree with that answer, right? So this pops out a point right there. See what I mean? Pi over 4. Root 2 over 2. Right? So immediately now we have a point that comes out right there. See what I mean? Okay. Pi over 3 and 1 over 2. Right? So for input pi over 3 we have pi over 2. I mean 1/2, right? So the output is right here. Right? So you can see that the pattern, the point start out at 1 and start dropping down as we go on to these different angles there. So you start seeing some kind of shape, right? 0. So for pi over 2, the output, right? Pi over 2 as the angle, the output is 0. Negative 1/2. So okay, 1/2 and then 1 over 2. Okay. All right. So you got a point right there at 2 pi over 3. You got a negative 1/2. So the next point is, now on my screen it's a little hard to read, but the next one here on my table is 3 pi over 4, like that. Negative root 2 over 2. Show this a little bit, so we'll hide that other thing again. Alright. So you keep seeing the shape pointing down, right? It's not exactly a straight line, but it's going bent, but it starts out high at 1, right? It falls down, crosses through, hits through the x-axis right at pi over 2, right? And starts sinking below those points there. Okay? Negative 3, right? Over 2, so right now we're at pi over 6, right? Negative 1. Thank you. That's an easy one, right? So it hits down to that. Negative 3 over 2. I agree. Right? For that angle specifically 7 pi over 6, right? Negative root 2. And the point is now starting to rise back up, right? And you can see that. All right, so let's continue. Negative, 1/2, 0. I like that, okay?
1/2.
1/2.
Root 2 over 2.
Next person is root 2 over 2?
Yeah.
Thank you. Okay, see, that's how you guys are getting to work more fluid. Okay, and you see the point is you keep observing the behavior of these points there, right? They keep rising up like that. Now some part right here is going to be for sure hidden behind the button on our graphing utility right here, so there's no way much I can do about it. Maybe I can adjust this right there. I can move this, so because we have already seen these parts right here, so I'm going to move that a little bit, okay? But so 11 pi over 6. That's the next one. Who's going to get that one for you? Root 3 over 2, positive, right? Thank you. Okay. See, and as we're repeating these problems right here, you guys will keep getting better and more fluid at that. Who's the next person for that 2 pi? 1. There you go. Okay. And so, at least these common angles, right by the time that we ended up at 2 pi right here, and we completed one cycle, right? So that's our table value. right? That's our table value. It goes from 0, and I have some other empty ones like that, and we're gonna come back to that later. But now let me hide away the table values here on our screen. Right? So the shape, you guys can kind of recognize that shape, right? See? From the left to the right, these points line up in some kind of structure like that, right? It falls down, cross through some kind of curve that falls down, definitely not a straight line, right? It again falls down, cross through the x-axis at pi over 2, right? Swing down, hits to a low at, how low is that? Does that hit? -1, right? Hits down to -1, and then swing back up right there and cross through the x-axis at 3 pi over 4, right? Come up to that. See what I mean? So now let me bring up the actual graph like that. So on that way, in that way right here, let me zoom it out. Because now you guys have seen enough with the partition right there, so I can just zoom it out. Then let me bring in the actual graph right there. Okay. So right now we have done the part of the graph that's only in one complete rotation, right? That's the graph right there. See what I mean? Right. That's the picture. So this picture right here, now we learned about the graph of cosine after we had already done the graph of sine. So think about it. We are, eventually I'm going to call, because when I was introducing the sine function, right, I was talking about the basic units again. Okay, the basic units. And so your cosine function also has that basic unit. It's a little bit different with the sine function, right? But the basic units kind of look like this. You know what I mean? And then we're gonna get even more into that. The basic units for, so cosine is like that, and then the sine that we've done already in the early lecture, right? The basic units goes like this. There's a center line, right? There's a midline right there, and then it swings up, swing down, and ends like that. Across the right, halfway. See what I mean? But here it's a V shape, and then we're gonna get even more into that. But very similar to the sine function. The cosine also is built. The graph of the entire cosine is built from one basic unit. And this is the one we have seen again. The graph will want the complete rotation. Right? So, but then there are a lot more. So let's come back to that graph right there and look at some more. So I still have that. So right now on my screen, right? Go ahead and find for me. So now you see on the grid right here, it's indicating 13 pi over 6, right? 13 pi over 6. Now, go ahead and quickly calculate the value, the output value, meaning cosine of 13 pi over 6. It's on your unit circle. So think about we go one complete cycle already and go one more pi over 6 away, right? It's 2, 3, I think. Over 2. I like that. Okay. And so in that way, the next point down right here. Right? I want the inputs to be, there's a pi over 3. And that's the angle right there, 1/2. And so, and we starting from this point, right? Because we already completed one cycle. That's why I didn't want to look at the whole graph anymore. But the point is, I'm starting at the 2 pi, right? The end of the first cycle, right? The end of the first rotation, and then I'm gonna think about I'm gonna rotate around my unit circle one more rotation like that. So now you guys see where I'm going. So the next angle here is the 5 pi over 2 right here. 0. Right. And I just now realized I actually missed one point between the 13 pi over 6 and the 7 pi over 3 right here. There was another one right here, and there's 9 pi right on the common angles. And then there's a 9 pi over 4. So root 2, right? Over 2. So do you see the behavior is exactly the same? I mean, if we start right here at that 2 pi, right? The behavior starts exactly. It's behaving the same, just like how these beginning points behave. See what I'm saying now? Okay. So, and we're going that way, that's putting a few more points again. Okay. So the next one on my list right here, how about 8 pi over 3? Okay. 8 pi over 3. Negative. Okay. 1. Right. I agree with that. And then there's a point that was not displayed on the script right here, but it's exactly between 8 pi over 3 and 17 pi over 6, so 11 pi over 4. Yep. Right. Now, what value is that one? Right. Negative root 2 over 2. You see, and when you're observing the graph, now you don't even need to always look at the circle, but you can observe it. It goes in that pattern. It's been positive, right? So now it's gonna fall down and continue to be negative until it hits some real low, right? Okay. So the next one here, you see, 17 pi over 6. Cosine of 17 pi over 6. 3, 2, 3. And then what about a 3 pi here? Negative 1. Right? Cosine of 3 pi is negative 1. Right? Yep. So we've got a point up down right there. Yep. So now, the next one we got 19. Fraction plus 19 pi over 6, right? And cosine of 19 pi over 6. Negative root 3 over 2. There you go. So the point is swinging back up now, right? It's making its way to hits back up like that. Right? So the next one here we got so right here it's that exact point halfway from the 19 pi over 6 to the 10 pi over 3, and it's another pi over 4 away. So I mean, what I meant was right here was 11 pi over 4, right? So right here, some 13 pi over 4. 12 pi over 4 was already this 3 pi I got on that. Okay, so now 13 pi over 4, what's the angle? What's the output there for cosine of 13 pi over 4? 2, 2. Right? And the next one right here. Be ready for that. Negative 1 half. Back up. Right. Then the next one, now we got a fraction. 7 pi over 2. Cosine 7 pi over 2. Alright, so that's enough eating around the bush, right? So now you can see that the wave once again repeats exactly just like how it was earlier. Now as I zoom it out, it looks like we are on our way to replicate that, right? We're replicating this graph portion right there. That's why the basic units here, we're going to just simply repeat that. And so yes, as a matter of fact, so now with my complete table, see that was only for one period. Now we're completing it. That's how it looks like that. See what, right? So now that confirms that hey, when we graph, that's why now the complete cosine function goes like that. It waves. Keep waving, and as I keep zooming out, okay, you're going to see the wave extends infinitely far, right? Keep repeating. So the basic unit was from here. This was our basic units. Our basic units was here. Hiding all the points away, the basic units was here. And the rest is just simply a replication of that, and keep repeating it. Okay? So let's look further into those into that basic units to understand it a little more so that we get more fluent into sketching it. So, the basic units on our cosine function, right? Basic units, or the fundamental units, right, of y equals cosine function. And here's how I'm seeing it. The way how the graph for now looks, right? The x-axis, very similar to, and you see it's waving, and so in the end, once you put infinitely many of those basic units together, you see that it's a wave that up and down, so in the end, there's a midline again, right? That's a center line, see what I'm saying now? And then once we chop it up into only one basic unit, and then when we only focus to only one basic unit in the basic unit wave looks like that, right? So let's dive in even a little further. Now, in the way how it looks, the basic units finished in one rotation, right? That's finished at 2 pi again, you guys agree? But then halfway of a 2 pi means we are right at a pi. What's going on with that? We're going to find out, right? The highest point at wave hits was a 1, and the lowest point the wave hits is a -1. That was from the picture, right? And then the picture goes like this. There's halfway point, there are the quarter points being, there's a pi over 2 here, and there's a 3 pi over 2. These are the quarters in the entire phase unit. Right? You guys see what I'm doing with that? And so the graph went like this. It hits low at the halfway point, it hit low, but how low? -1 was a low. Right? It started out high, and it's ending up also at the same height, being at 1. And then right at those quarter points, the graph crosses through the x-axis. So here's how I generally see it. It's a cup down, right? It's a cup pointing up this way. It's another cup. And just try your best to make the best shape, that's all. And then it's another cup that's pointing down at that. But that's your famous V shape. That's the major feature of your cosine graph. You guys following? Right? There's the starting, again, the start is here. Right? You got the start, and we got the end right here, right? And you know what I mean? Right. And then the total, the entire interval length where your basic unit stays in is a 2 pi length, right? It's a whole 2 pi length again. So, very similar to very similar to sine function. Cosine of x, right, is a, you see, because it's repeating that same basic unit. What was that name that we used for cosine of x function? It's a periodic function. Because it repeats every fixed period of time, I guess, right? Or fixed period interval. So, periodic function. That's number one thing. Very similar to the sine of x, right? Cosine of x is also a periodic function. But once you're done with one period, right, then the next period over, it's going to repeat exactly like that again. It just replicates. And then even before, think about the negative angles, right? We could have had even more those the exact, but the shape right here, but copy and paste on the left side of that, right? Before we hit to that basic unit again. Right? And then so for this one right here on that basic unit, here's what we know. Some more information about that. We want to know. See, it's got there's a center line, right? Center line, or sometimes I may also call it a midline. Right? What's that line there? For this specific function right here, y equals 0 for the x-axis. It's right through the graph, right? And then I've been pointing out, and similar to the sine functions, being a periodic function right here, it has a one total window where it completes one basic unit, right? The basic units here complete in one certain window's length or one interval's length. And we call that informal name is a period. Right? Sounds good. So how long is the period of your graph here? What's the total interval for here? 0 here is stopping at 2 pi. So what's the length of that period? Period equals 2 pi. Right? The total length of that interval right here. That's what I'm talking about. Being a 2 pi distance. Now this spot itself right here is reference to 0 right there. That spot is marked 2 pi because it's the end point. Right? So start for this basic unit is at x equals 0, right? And then the end point for that unit is at x equals 2 pi. But see, always pay attention to the fact that the end point, right, is always equals to the starting point, right, plus the period. Okay. This is what we have also mentioned in the earlier lecture over here. So the period here being 2 pi, that's why end point is 2 pi. Simply start at 0, right? We add 2 pi period, then we end up the end point. That's one common rule about getting notes. So that's now enough to with the beginning introduction right here. Now let's get into some examples. Another information about the wave here as well. It also has a See, the distance being away from the center line, right? We call it the amplitude. So for this cosine wave, the amplitude is also 1. So sine wave and the cosine wave has the amplitude 1. And before we get into that example over here that I wanted to show you guys, and once again, let's get comfortable with sketching, just sketching the basic units for the sine and the basic units for the cosine. Okay? Remember, here's how you look at the sine right here. For one basic unit, there's always a center line, horizontal line, right? There's a start, there's an end, see, midpoint, halfway, right? And then the quarter points. So the structure of your sine function goes like this. I don't even need to put numbers in, but when it's quarter point, it hits a high. When it's the third quarter, it hits a low right here. And these points right there, the starting, the ending, and the halfway point right there, that's where the graph crosses the x-axis, or crosses with the midline. So your sine wave looks like this, regardless of having the axis is on or not. See what I mean? See how simple that is? Okay. See, once again, draw the center line, right? Do it with me right there. Starting point, right? Ending point, whatever that is, we call it the period, right? Halfway points right there, easy to quickly sketch, right? And then you put in the quarter point right there, which is also easily sketched by putting in the half of those halfway points. And then so now at the first quarter we swings up, right, to some height. Second quarter we swing down right there, right, to a low right there, and the graph goes like this. See, swing up, right. Swing down. See what I mean? Right. Swing low right there and swing back up right there. That's the graph for cosine. Good. So that's for sine, right? That's the primary structure right there. So, and the basic sine right here, y equals sine of x, right? Here's how I'm seeing it. See, you put the x-axis, you put the y-axis right here. That's the y-axis, x-axis. So that starting point has to be 2 pi, right? I mean, ending point has to be 2 pi. Start at 0, right? Halfway right here is a pi, and these right here, that's a pi over 2, and that's a 3 pi over 2. See how simple that is to sketch the sine wave right there. It's a wave, right? But specifically for the sine function. And then for the basic sine function, see, once you make your drawing, that scale right there of yours, that's 1. Right? That scale right here is -1. Back in this case right here, see, in any of the version, after you got the start, and 2 pi is here, 0 is here, halfway is a pi, right? How high it hits, that's the amplitude, right? It hits 1, because that's a sine function. I'm talking about how we train ourselves to draw the basic shape, and it hits down at its lowest, -1, right? And there's a pi over 2, and there's a 3 pi over 2. Sounds good? Now when you're looking at the cosine, just like that, right? And this is even before any example over here, we just want to get comfortable with that drill, right? You sketch the graph of your sine and the graph of your basic units for the cosine. So the cosine here, once again, there's a total, the period window, right? The start here, it swings like this. From high, it drops down to 0, right? Continue, drop down to hit the low right here at the halfway point. So at those quarter points, the graph of cosine crosses the x-axis, right? Crosses the center line. You guys can feel that? And then it swings back up and hits the high again, back to the same height at the end point. You guys see what I'm saying? No? And then when you think about it, when you close your eyes and put in your imagination the shape of that basic units for the cosine is like a V shape, a nice bent V shape. It's not the hard V shape like the absolute value function that you guys have seen back in pre-calculus 1, but here it's a nice curvy V shape like that, right? So let's practice. Let's practice with that scale drawing, and remember the amplitude is always a 1, right? So let's just practice. This is just practice drill right here. Okay. So y equals cosine. See how I'm doing it, and you can just also do that yourself. Okay. See, when anyone is asking you to sketch cosine, right? And the way we do right now, we focus to just being able to do that in one period, and that's perfectly good, because once you can draw the graph for one period, right? That is the basic units, then you can keep repeating it for the rest. See what I mean? So, the center line, see, draw the center line first. Okay, draw the center line. Wherever you want to start that, right? Wherever you want to end that total interval right there, that's the period. So starts here, end is here, right? And then you can easily pick the halfway point here. You guys following? Okay, halfway point, and then after that, we can easily break it down to those quarter point. Are we good with that like that? Okay. And so now, but here's the thing, for the starting point right here, it started at some height, right? And then quarter, remember the structure of the cosine of the quarter, it has to hit the x-axis. So it goes like this, right? And then at the halfway point, it got to swing to a negative, so it swings down like that. And then it swings back up, and then it hits the x-axis at the third quarter, right? It ends right here. There's that V shape again. See how I'm doing it? Right. And then so right here with that starting point, you put the y-axis like that. Right. And then right here you call that as a 2 pi, right? The center line is of course the x-axis. Okay. That's how you got the graph, right? And then so this, once you got that right here, you define that scale right here, right? It's defined as positive 1. See what I mean? And then the low point it hits right here vertically, we define that scale to be negative 1. See how easy that is? Right. And then ending at 2 pi right here, starting at 0, then of course that halfway point, we call that, let's say, the pi, right? And then the quarter is pi over 2, and pi over 2. See what I'm doing there? So the hand motion went like this, from high, right? Swing down, see what I'm saying, right? From there, the center line like that, right? Swing down further, and then swing up, right? And it's that. That's the hand motion for it. Right? Make sure you put that in the curve, the shape like that. So, now after we've learned 2 lectures back to back, right? Now we're starting our first example. Let's say I want you guys to sketch, right? Sketch the graph. Two separate sketches actually. Okay, sketch the graphs of sine of x, right? And the cosine of x. 2 graphs. But now I got a requirement for you. For about 2 periods. See what I mean? So this is a formal term that I mean. What I mean is I want you guys to sketch these things with 2 basic units back to back. See what I mean? So that's how formally we say sketch those graphs. Each one of these graphs for 2 periods. That's how it says. Okay. And then and starting at x equals 0. How's that? Two periods, right? Hopefully after the drill that you guys been comfortable enough with sketching the basic shape for sine and cosine, right? But now we want to put in more equations. See what I mean? So let me lead the way with us. Now let's sketch the graph of sine, right? But we want 2 periods. Okay? 2 periods. The sine is now, see, like that, right? But 2 periods. Starting at 0. So here's my center. Okay? You draw the center line. See what I mean? You can just pick that point right there, and pick the point we call it start. You guys following? And then there's the end, right? However far the space is, you make your choice of that. But start and end. Right there, that's just 1 period. You see what I mean? Okay? Start and end, that's 1 period. So just like that, you're gonna be successful once you can get 1 period down, first of all. So start right here, okay, and right here, we want to say start at 0. That means we put the x-axis right there, right? You guys see what I mean? X equals 0. Start, right? And so the end is a 2 pi in the way how we've been doing it, right? Because if we're starting as requiring as instructed here at x is 0 equals 0 for the start, and that's right there. And the end of the window is here. So again, halfway, just like that, right? For the first basic unit right there, halfway is a pi. the quarters are pi over 2 and degree pi over 2. Is everybody with me still? Right. And then so now see, we pick a point up here at the quarter, we pick a point down here, right, at the third quarter right there. We call that height there 1, right? That's label height below the negative 1. So now here's the graph. Just like that, still you guys have been doing it. Swing up, right? Swing down, hit 0, swing down even further to hit negative 1, right? And swing back. Are we good? Okay. So that's the graph, but only one period so far. You guys see what I mean? So that you're repeating that still for one period. But now you want to do one more period. You already have the starting point. The starting point is done. It's good. Check with that, right? But now you want to do one more period because you have done one. So one more period. From here, think about it. One more period is supposed to be the exact same length like that, right? One more period to the right-hand side. So if it was a 2 pi over here, then another period aside away from that, right? It has to be a 4 pi, am I correct? Because your total space here, your total spacing here is a 2 pi, right? You guys follow that? Right? So once you sketch down that next window over there, right? That second window, that second period window at the 4 pi, then now it's easy. Halfway of that second period, right? Is a 3 pi. You guys good? Right? And then we put down the quarters again, right? Those quarters, and then we once again at the quarters we hit first quarter in any period, right? First quarter in a period we hit high, third quarter in a period we hit low, right? And the midpoint where we hit the x-axis. So we swing up, we swing down, we swing down, and we swing back up. Yeah, up to 0. You got that. Sine wave for 2 periods. Am I making sense? That's the way how we do this, right? We don't need the fancy graphing utility. Yep, and that's complete. See, 2 periods starting at x equals 0, right? And so just like that for my cosine, we're still in part A of the example, right? My cosine we want to do. So once again, I want you guys to get into that habit. Draw the center line, right? Whatever that start, we call that start at 0, so we call that the start. And right here, right? And then if we want to start at x equals 0, you put the y-axis right there. So this is where x equals 0, our start. Right? And then so the ending here has to be a 2 pi, halfway, quarters, right? But for the cosine, see, we think there's it starts high, so let's call it 1 right here. Right? It starts high, it drops down to right at 0, right? And the quarter, the first quarter, and it drops further down to a negative 1 down here, right? You set your scale for how far 1 is. Right? I'm a little bit off already. Just trying to make it a few more distance. Yeah, that's what I'm looking for. Right? See that there? Right? And then swing back to that third quarter, right? And then swing up here. See that famous V shape right there? So that's 1 period, starting at 0. 1 period, right? But now we want 2 periods for the cosine. How do we do that? Right? Another space like that, right? To the right-hand side, so like copy and paste. So there's right there, that's a 4 pi, right? So now in that next period right here, in any period, right? In any of the periods, halfway, well, numerically labeled 3 pi, right? Halfway is where your cosine hits a low, like that. Quarters is where your cosine hits the axis, right? The center line. So now once again, that graph drop like this, right? Drop down to negative 1. I made my negative 1 a little too far down like that, right? Hits back to a 0 and swing back to a 1 like that. And now you can go ahead and label these a quarter point like that. Am I making sense? Right? That's how you do it. Right? So how about part B? Now, maybe this is the first time you guys hear from my term here, but FYT means once you write it down, it's for you are trying independently. Okay? So I want you to sketch sine and cosine for 2 periods again. Okay? 2 periods, but how about starting at x equals minus 2 pi. How's that? Okay? Write this down. try it on your own with them. And in the next lecture, I'll have a look at that.